As I look at this integral and think of the integral tables, actually there's nothing on the integral table that has this integral in sort of a quadratic ax squared plus bx plus c thing. But I remember, and specifically even from the last example, that there are things on the integral table that have a quadratic that has an ax squared plus or minus an a squared. And I know on any quadratic that I could complete the square, and then if I complete the square I could actually use the same formula that I used before. So that's what I'm going to do here. So I'm first of all going to complete the square here and have x squared minus 4x. Now to complete the square I need 4, and I actually have an 8 here, so I'm just going to split that up like this. And the reason I'm going to do that then is this will factor as a perfect square, and that's what I wanted to do here. So now I will have the integral of the square root of x minus 2 squared plus 4 dx. Now looking down here at my formula off from the integral table, then if I let u actually be x minus 2, this piece right here, then du would just be, so then I would have the integral of the square root of u squared plus 2 squared dx. So I can see that my x down here is u and my a is 2, and I want to use the plus. So this is going to equal 1/2 u times the square root of u squared plus 4 plus 1/2 times 2 squared, so 4, times the natural log of u plus the square root of u squared plus 4 plus a constant. So then the last thing we need to do is resubstitute for u, and we will have u was x minus 2. So we're going to have x minus 2 over 2 square root of, and we could take this x minus 2 and write it as a squared, but by the time we multiply that out and added 4, it's going to be this original thing underneath the square root. So let's just go ahead and write it like that. 4x plus 8 plus 2 natural log of x minus 2 plus the square root of x squared minus 4x plus 8 and plus a constant.